Sorry about that. You ready? Hi, my name is Landon Hazel. I'm going to talk to you about the Stirling engine. So, if you've heard of the Stirling engine, it's a pretty cool concept. It's vastly different from an internal combustion engine. So, an internal combustion engine has a fuel that is, and they inject the fuel into the engine, and then it's got like an exhaust and stuff. A Stirling engine actually uses an external heat source to power the engine, and there's a specified amount of gas that's in this particular volume, and the gas doesn't ever leave the system. It's permanently in there. And it can use any heat source to power the engine. One example that I found online was like decaying plants. They would use decaying plants to actually power a Stirling. And that would be a very slow process, but it would just be gradual energy that it wouldn't lose. So this gentleman is Robert Stirling. He invented the heat economizer, which he improved thermal processes, or thermal efficiency of like some industrial processes. And in 1818, he built the first practical version of the Stirling engine, and he patented it. And then eventually he quit doing engineering works, and he became a minister for like 50 years. So who knows what he could have done in that time. So the key principle of a Stirling engine is that there is a fixed amount of gas in the reservoir that is sealed inside the engine. There's the two properties of gases that are critical to the operation of the Stirling engine. So if you have a fixed amount of gas and a fixed amount of volume, and you heat the gas up, then it's going to increase the pressure. And if you have a fixed amount of gas and a fixed amount of volume, and you pressurize the gas, it's going to increase the temperature. So it just kind of works in alternating methods in order to get the result of a rotating engine. So there's 4 steps to the Stirling cycle. The first is that heat is added to the gas inside the cylinder, which you can see. This is the hot cylinder. This is the cold, or the hot piston and the cold piston. So the heat is added right here, and it increases the pressure of the gas inside there because it's a constant volume. And it forces the left piston to move down, and this is what actually does the work and produces the work. And then the left piston moves up while the right piston moves to the left. This pushes the hot gas into the cooled cylinder, which quickly cools the gas to the temperature of the cooling source, which could be like air or water. This makes it easier to compress the gas in the next part of the cycle. And so then the piston in the cooling cylinder starts to compress the gas and shoves it back into the heating cylinder. And the heat generated by this is removed by the cooling source. And then the right piston moves up while the left piston moves down. This forces the gas into the heated cylinder where it quickly heats up, building pressure, at which point the cycle repeats. And so there's different types of Stirling engines. What we were just looking at was an example of the alpha type. It just contains 2 different cylinders, or 2 different pistons. There's one hot and one cold piston, and it's got a really high power to volume ratio, but they don't generally last as long because the hot power piston ends up like just warping over time because of you have to put so much heat into the cylinder. The beta has a single power piston with the displacer piston on the same shaft. This is a good method because it avoids hot moving seals. And then the gamma type, it's like the same thing as the beta type. You can see that the reservoirs are the same, except the power piston and the displacer move on different pistons. And I don't really know how to explain because I couldn't find anything on the double acting type. It looks pretty advanced though, so I'm not going to mess with it. So there's 2 ways that you can improve the power during the Stirling cycle of the Stirling engine. You can increase the power output in stage 1 by basically just increasing the heat, and so that whenever you heat it up, it's just going to cause more pressure buildup. And then you can also decrease the power usage in stage 3 by making the air or the water, making the cold cylinder much colder, and then it's just much more efficient because the temperature changes are higher. So this is a super efficient engine. Why aren't they more popular? Well, the main problem is that the heat source is external. It takes time for the cylinder walls to build the heat up, and so it's got a very slow startup phase, and it takes a while to warm up before it can produce useful power. And then once it does start producing useful power, it's not like a internal combustion engine where you can just put more fuel in it and cause more power. You're basically at the same power, so it would have to run something like a generator for it to be used efficiently, because you wouldn't be able to change the power output. So you wouldn't want to use it in like any type of work application. And then there's my references. Are there any questions?
So, what is the efficiency of these kind of engines?
I couldn't find because there's so many different types, but
The basic one.
I think I don't want to lie to you, so I don't have an exact number. I think it kind of depends on what exactly you're heating it up with, because if you're using the decaying
You
plant.
can look at the stages, right, and find the
Right.
see where we use heat and where
Right.
we use work.
Yeah. So, but I know it's much more efficient than the Otto cycle, the internal combustion engines or stuff like that. But yeah, it comes at the fault of not being able to change power. So.
We must be losing heat when we heat up the engine. At that time, we actually lose some heat.
Right.
Right in the process.
Right.
Through conduction or radiation.
Right.
But it must be greater than the gasoline.
Yeah, definitely.